Close all that. All right. Hey, hello everyone. Yeah, welcome to live stream number 6. Yeah, we're gonna start off, kind of demonstrate the ros-bridge and the support for using ROS to control the Amiga that we've been working on for you people. And yeah, I'm Kyle, one of the engineers at Farm and G, computer vision and robotics.
Turn up your audio.
I guess everyone else want to introduce themselves. The ros-bridge, the support for using ROS to control the Amiga that we've been working
all
on
around robot
for
guy.
many people. And yeah,
We have
I'm
Edgar in
Kyle, one of
Spain.
the engineers at Farm and G.
Hey, hello,
Vision
I'm
and
Edgar.
robotics.
I'm also one of the engineers at
Guess everyone else
Farm and
wanna
G,
introduce
working
themselves.
on computer vision on the Amiga side. Yeah, very excited to be here.
And we've got Hector here also.
Ryan, you have some pretty bad echo.
Hanging out there with the robot.
This is me, Hector. I'm working for Farm and G for almost a year. Thank you.
Hector's a expert machinist and now helping us do continuous operations on the farm.
That's right. Okay. Yeah, can we maybe I'll show my screen for a little bit.
Yeah.
We bring up. So we'll kind of start off, we'll introduce ourselves and introduce this. We will talk through the ros-bridge repository, totally open source, so you can look through it and use it. Then we'll demonstrate deploying the ros-bridge on the robot. And so we have 2 ways of running it. One is with the ros-bridge actually running on a Docker container on the robot. And the other method is where you run the ros-bridge on your computer and connect to the robot over gRPC, which is our normal way of controlling it. So for those demonstrations, for deploying it on the robot, we'll have Ren and Hector there showing that, since they're boots on the ground. And then for connecting over gRPC, you can actually do that from anywhere in the world. So we'll have Hector demonstrate that from Spain. And then, yeah, open for discussion and questions. So please post in the chat if you have anything you want us to cover or talk about, or questions about anything we say. And yeah, we want to get some feedback on how you plan on using this ros-bridge so that it can kind of guide the direction we take it going forward. So we'll click over to the ros-bridge. It's FarmNG amiga-ros-bridge is the name of the repository. So we've written the ROS-bridge in Rust, which that'd be kind of fun to try that out. And we've made this as a method for if you want to control the robot using ROS nodes or existing ROS path planning and following nodes to make it easy for you to connect to the gRPC CAN bus control of the robot. So right now the interface is to communicate over twist messages using the geometry messages ROS package, which is kind of the standard. So the ROS-bridge listens to the topic amiga command vel, which is just a twist message, and then unpacks those messages, forwards them over to our CAN bus gRPC service in order to control the robot. And then at the same time, the ROS-bridge streams on the amiga vel topic. It's streaming twist stamped messages, so it's streaming what it measured, the linear and angular rate that it measured the robot drove, and the timestamp of when it measured that happening. Yeah, so we have 3 methods of running this. I alluded to 2 already. So the first method is you run the ROS-bridge on the Amiga. That means your ROS master will be on the Amiga. And then you can connect other ROS nodes running on your PC or some sort of server connected to the ROS master on the Amiga using, well, the ROS master connection. The second method is that there's actually no ROS running on the robot, and you only run ROS on your computer. So you run the ROS-bridge on your computer, which then connects to gRPC through, I guess, I don't know, setting the host in the gRPC connection. And then we have another method for running, which was sort of just set up for us to develop this, which is this mock server. So you can run the ROS-bridge and connect to the mock server, and then the mock server will just echo back whatever you sent as the command vel as the measured velocity, just to kind of test and give you sort of a round trip. Yeah, no promises that we keep that up to date. It was sort of a dev tool as opposed to like part of this product. Though if there's high demand for it, of course we can prioritize keeping it up to date. Which is something you can let us know in the issues for this Git repository or on the FarmNG discourse. You can start a conversation there about anything. Okay, so the repository and the README on the main page, that's where all the documentation for this is currently. This is a new tool, so we're constantly iterating on it and trying to improve it, and your feedback will direct how we work on that. So just keep checking here regularly. We'll try to announce on the discourse whenever we make updates and improvements, but also things may change, the install methods may change, things like that, in order to make it an easier to use tool for you. So these are the current instructions for running this, but yeah, subject to change as always. So in here, just since we do have all these methods, we've kind of listed them as method 1, method 2, and method 3, just to keep things straight in the documentation and not have a lot of the same instructions copy and pasted around. So method 1 is running the ROS-bridge on the Amiga again. Method 2 would be running it on your computer. So you'll see those kind of tagged around. If you're running it on the Amiga, currently it doesn't come in the Amiga ROS-bridge Docker container. We haven't pre-built that in that Docker container. That's probably a change that'll come at some point. So for now, you go through the full installation process where you'll clone this repository and install the ROS-bridge or build the ROS-bridge on the Amiga itself. And if you're running the ROS-bridge on your computer, you of course have to go through that process. Some prerequisites: ROS Noetic is what this ROS-bridge is built for. And since it's used with Rust, you'll have to install Rust if you want to build the ROS-bridge. Both of those are, very well established open source tools. So just refer to those instructions for installing and setting those up. Yeah, so we'll kind of go through the installation process. So I'll glance over this a little bit. But yeah, so you'll create a captain workspace. Of course, if you're a ROS user, this is all very familiar sounding things to you. You'll create your captain workspace. You'll clone this repository and build it in there with cat can make, which is how you build any ROS tool or ROS package. And then we have some detailed notes on the connecting multiple devices over the same, running on the same ROS master, which also is a well-documented method of running, I don't know, ROS on multiple machines, well documented by ROS and discussed thoroughly in the ROS Q&A. So you can always refer to those links for that information. And then, yeah, we talked through how to launch it, how to run it everywhere. And then we have different ways of testing it and actually driving the robot remotely. So we will demonstrate all of that.
Maybe Kyle, you want to comment about that? We are gonna release also a Docker image, including ROS, PyTorch. This is something that yeah, you need to request from us. Yeah, maybe you can mention that a bit more. What will be the process and what implies or what can you do and you can not do there?
Yeah, so the Docker container, as Edgar mentioned, it's a ROS Noetic and PyTorch supported Docker container that you can install on the Amiga. It'll be a separate Docker container from the Amiga apps container, where that's kind of your Amiga operating system where your launcher is. You control all the services and everything like that. It's a separate container from that. You can install it. So one, you could reach out to us and we can install it for you very easily. Or we're having a tool that'll be posted on Discourse. If it's not already posted, it'll be posted very soon today, where you can make a query to install that yourself. Yeah, it's okay. So Chris actually just slapped me. He's posting that in Discourse right this second, where it's a curl command that'll install that on your robot.
Cool.
Yeah, good point. And then for connecting to the robot, you'll SSH into the robot, just like you'll sometimes do with the Amiga Docker container. And then we will reach out to us for that password for accessing it. Don't want to put it publicly available. Okay. So maybe now we will. Oh yeah, sorry.
Yeah. Saying that maybe we can show that now how it works, right?
The downloading it tool. I'm not able to demonstrate that right now. I guess I could try.
Otherwise,
yeah,
I mean,
maybe
no, yeah.
Yeah,
or
maybe we can
SSHing
demonstrate
to
that
the container
towards the end.
Mm-hmm.
But yeah, I'll show how to access the container.
Yeah.
Okay. Clean up my terminals a little bit. Okay. So when you want to access the ROS container, you can SSH in. The ROS container runs on port 2222, uses the username ROS, and then here, so the devices run on Tailscale, so we'll use the Tailscale name pretty often. But you can also use the IP address of the robot, which is, I believe, how you'll normally SSH. Typically, I think you would SSH Amiga at, and then your IP address, which maybe, for this one would be 192.168.100.247, which is an IP address you can use if you're on the same network as the robot. Because I'm in New York and the robot's in California, I can't use that IP address. I'll have to use the Tailscale IP address, which is equivalent to using the Tailscale name. So yeah, dashport 222 ROS at the IP, enter the password. and you can SSH in. We like to use this BYOBU terminal, just kind of a convenience since we're working as a distributed team. So this is by no means something you need to do. I guess I'd have to install it if I want it. But this way, Ren, who's there with his computer, and I can share and use the same terminal. So I'm going to install that. And open one up. Okay, and then I think Ren, you would be able to join this terminal.
Yeah.
Okay. Yep. Okay, so you can see Ren's in. So one of the things that this tool does is the smallest terminal wins. So you'll see that my terminal is shrunk because Ren logged in with a smaller version of it. He's not using the full screen. And now he's having some fun. Okay, and then maybe I'll put this side by side with our instructions on building the robot. So again, for right now, the ros-bridge does not come precompiled and built in the Docker container. We're hoping to have that for you in the near future. But for now, you'll go through this process of installing the ros-bridge yourself. That starts with creating a Catkin workspace. Again, very standard ROS practices. We've already made one, just because that way you don't have to sit through the compilation time, which can be a little slow. But I'll still kind of go through that whole process. So you would source your ROS installation, opt-ros noetic setup .bash. Then you would make a directory. You'd make a Catkin workspace, src. I'm not actually going to run that because we already have it. You would navigate to the Catkin workspace and you would Catkin make. This would make your build directory and set this up as, and your develop directory and set this up as a Catkin workspace. Once you've run that, you can source. Now you can source your Catkin workspace. And if you're not familiar with Catkin workspaces, I guess like with ROS, you can kind of build on top of workspaces. So this Catkin workspace, before it was built, it sourced opt-ros noetic setup.bash. So that's like the base ROS installation in this Docker container. And then we take everything that has and we start a Catkin workspace on top of that where we can install other ROS packages, which in this case will be the ros-bridge. You could then start a new Catkin workspace on top of that sources this Catkin workspace and has the ros-bridge and anything else you install, or you could just install those other things in the same Catkin workspace. So yeah, so now we have this Catkin workspace, it's been built, and we can go on to installing this repository. So Catkin workspace, then clone this repository. We would go to cd Catkin workspace src. You'll see here we already have the amiga-ros-bridge, so we've already cloned it. See, it already exists, so we can't do it. You'll navigate to that ros-bridge, and then one thing that's important, which if you're not a super experienced Git user, kind of an important thing to keep in mind. So we have a submodule in this repository of our farmng amiga repo. So what that means is there's basically an empty file that just points to that repository and a specific commit of that repository and includes that in the code. And in order for that code to actually be included, it doesn't come when you git clone. You have to add that submodule with this git submodule update init. When it's the first time you run it, it'll take a little bit longer than that because it'll say like cloning the farmng amiga repo. And then from then on, anytime that changes, you can git submodule update and it'll update. And when you do a git status here, if that is pointing to the wrong version of farmng amiga, it'll say that there's a difference there and red letters, and you can run git submodule update in order to update that. Okay, and then once you have the repository there, you can go to back to your Cactus workspace, and you're ready to build. So you want to make sure that you have the Cactus workspace sourced. So you'll navigate there, you'll source Cactus workspace devel setup.bash. Then you can Cactus make clean, which you don't have to do, but sometimes just kind of nice. You want to make sure you have a clean slate. And then you'll run Cactus make. So we've already run this on this robot, so that you don't have to sit here and wait 25 minutes for this to build. And that's also a big part of why we want to get this included in the Docker container, is that when you are using this, if you go to use this right away, you will have to run this Cactus make command and then walk away for 25 minutes or do something else. Maybe get a coffee or something. But since we've already done that, it's starting from step 585 out of 595, so it'll run a little bit quicker. And since we've already built it, I think I can just cancel this. Yeah, so now you have compiled code. One way you can check that is you could do ROSpack list, and that'll show you all of the ROS packages that are installed. Every single one of these. Oh, BYOBU doesn't let you scroll up well. Every single one of these is coming from the source, coming from like your Cactus workspace being built on top of opt-ros noetic bash. But we also have, and if you want to grep Amiga, you can see that we also have this amiga-ros-bridge ROS package installed. So now that we have that installed, we're able to run it. If you just want to run it locally, you could just run, we have a launch file for it, ROS launch, amiga-ros-bridge, amiga-ros-bridge.launch. And this would start the ROS bridge up locally. And you can see we've initialized the amiga-ros-bridge node. We've connected to the gRPC service, localhost 50060. That's the CAN bus service, CAN bus gRPC service running, and we're connected to that server. However, because we want to be able to connect to ROS running on the robot, but from another computer, we'll actually follow these instructions about specifying the ROS master. And yeah, if you've run ROS with multiple robots, this should be very common. They're very familiar to you. But yeah, so you have to specify the ROS master URI. So that'll be http:// and then the IP address of the Amiga, which you can get from the bottom right corner of your screen. So for this robot, it's 192.168.100.247. Remember in the instructions, so just type that before I forget the number. In the instructions, whenever there's the sideways carets surrounding something like Amiga IP or DevStation IP, you replace that whole thing, including the brackets. So you set the IP, and then we use 11311 as the port, which is kind of the ROS standard, what they recommend. And then you also need to export the ROS IP. And so the way this works is you'll have the same ROS master for everything that you want to run on the same ROS core. But you'll have a different ROS IP for every device based off of their local IP address. So here the IP address will be the same, 192.168.100.247. So now when we launch the amiga-ros-bridge, it's streaming on this public ROS master that another device can connect to. Since I'm not there, I can't connect to it. So maybe we'll pass it over to Ren's screen, and we can have Ren show connecting to this ROS master from his computer.
Mhm.
Instructions were.
Yeah, it seems it's connected, right? Yeah.
So Ren,
Yeah.
okay, cool. So you're gonna SSH into the robot. You'll need to give the port, I think,
Yeah,
for the
thank
ROS
you.
container.
Yeah, that probably shouldn't show. I guess we can.
Oh, you try to do it's distinctions, gyrations, not
Oh, okay,
frustrated
yeah.
Parcheesi's. Yeah, fun names.
Mm. Okay.
And again, for that password, in order to SSH in, yeah, just email us info@farming.com, and we'll share that with you. And you can share it with your team. We just don't want to post it or say it publicly. So,
geez,
Ren,
geez.
do you want to just connect to the BYOBU terminal I'm in?
Oh yeah.
Okay. So yeah, so I already have the ros-bridge up and running. Otherwise, Ren would start it there. But equivalent, and then so now you can, Ren, you want to go to a terminal on your laptop?
Yeah.
So on your laptop, and I'll just kind of talk through while you're going, Ren. You can also set up a Catkin workspace. Most likely you will, because you'll probably want to try both methods. The other method that Edgar will demonstrate in a few minutes here. Yeah, so if you don't build a Catkin workspace, instead of sourcing Catkin workspace devel setup.bash, you can always just source opt ros noetic setup.bash, because you don't actually need the ROS bridge for this step. So yeah, so from your computer, you'll export the ROS master URI. This will be the same as you did, and you did ROS macer, sorry. I think
mhm.
yeah, you'll do the same exact ROS master URI command as you did on the robot. That's saying we're on the same ROS master, but the ROS IP is what'll be different. And Ren knows the IP on his machine is 192.168.100.222. But if you want to just show an I, just to show where you got that from.
Yeah. Well, sorry, you broke up. What was that?
An IF config.
Okay.
Yes, so the WLP2S0 INET address is the IP address on the Wi-Fi.
On this machine, yeah.
Mhm.
Yeah, so he's, as the instructions show, he's sourced ROS. He's exported the same ROS master URI, and he set the IP to be the computer. So now what Ren should be able to do is do a ROS topic list in the one with the IP address and the ROS master specified.
Too much on all too.
Always. So now he sees that he's connected to the ROS master that's running on the Amiga. If you open another tab, Ren, just to kind of show people something they might run into, just in this terminal. If you try to do ROS topic list without sourcing ROS, not found. Okay, now if you source ROS, and why don't you source /opt /ROS /noetic /setup.bash. which is again the ROS installation that Captain Workspace is built off of. So now it's unable to communicate with ROS master because there's no ROS master running on your local machine, and this one isn't configured with the ROS master URI and the ROS IP. So if either of those are the issues you run into, it's because you haven't configured the multiple machines properly when the ROS bridge is running on the Amiga. Cool, thanks, Ren. So now if you go back to the other terminal that was sourced properly, not on the robot, but that one. So now you could do a ROS topic echo amiga-vel. And so now on Ren's computer, he's seeing the velocity that the robot is experiencing. And I don't know, if Hector, if you're over by the robot, do you want to drive it around a little and we can see the values change in real time?
You just want to drive it backwards manually?
Mm-hmm. Yeah.
Then like turn in place on the concrete here. Now we should see.
Cool.
Yeah.
Also seeing there's some questions coming in, Diego and heads up, and Ethan's responding to those. So thank you for using the chat. It's pretty cool. Yeah, for HESUP, we haven't streamed the images yet. We are thinking that since we're using Oak cameras, Luxonis supports depth AI ROS. So first we wanted to expose control of the robot, and because that's kind of the primary I think need, and then second will be next will be adding support for using the depth AI ROS library. But ideally this looks like installing the depth AI ROS package in this ROS container, and then being able to just connect to that directly as opposed to needing to bridge it. So we wouldn't want to go through gRPC, get the image, and then create a ROS bridge that then sends the image out when we can just use depth AI ROS to test directly. So yeah, it's a good question, and that's the next step that we'll work on. And then the speed, I think that would be totally dependent on your network. As you can see, maybe Ren's video while he's out on the farm and Hector's, maybe they're a little laggy. So we don't have like an amazing network out there. So I think this will be a really good test bed to see how the image communication speed over the ROS master will be when the network isn't, a gigabit Wi-Fi that you'd have in your home. Okay, cool. So we've seen that it can drive. Now, Ren, do you want to drive the robot? So if Hector can put it into auto mode, if it's not already, hopefully you all have used the dashboard and gone to the auto screen and set to auto mode, are familiar with that. And then, Ren, you'll use the other terminal. You'll do this from your terminal. So that one. So one easy tool to use, and we point to it in the README for the ROS bridge, is the RQT robot steering, which is just a really simple velocity publisher. So this comes with the base ROS installation, or at least the minimal desktop installation. I think it's in the base packages as well. If not, you can always just install that tool or that ROS package. And so, so Ren can now run ROS run RQT robot steering and RQT robot steering. So this will pop up, this GUI. Again, this is running on Ren's laptop, connected to the ROS master running on the Amiga. And then one thing you'll need to do is the default message topic up top starts out as command-vel, but you'll change that to the topic that we're listening for in the ros-bridge, which is Amiga command-vel. And this package doesn't stream velocities when everything's set to 0 like it is right now. So the robot should be sitting in auto ready because it's not getting any commands. And then as soon as Ren kicks up the speed, if the dashboard is in auto ready, it should kick into auto active and start driving. So maybe we can try that.
And yeah, it's driving.
Yeah.
And
Yeah.
yeah,
Maybe
so
also-
you can see it. Sorry.
Yeah. Maybe also mention that about the topic, because I think the default one is a / command-vel. So ideally, yeah, you should have to specify that it's / amiga command-vel.
Yeah. Okay. Cool. So yeah, so the RQT robot steering is obviously a really simple, available ROS package for driving the robot around. But this is a direct drop-in replacement for more advanced ROS control tools. So for you, the user, all you need to do is you can run whatever ROS nodes that you want to run on your laptop. The final thing that should be published should be a twist command to the topic Amiga command-vel, and that will control the robot. So yeah, I think that's this method. Maybe we'll switch over, unless anyone has anything they want to add, to Edgar showing method number 2.
I think it's fine for me. Yeah.
Cool. So yeah, so again, method number 2 will be, instead of running the ros-bridge on the Amiga, you can run the ros-bridge on your computer and just connect to the Amiga over gRPC. This is all kind of hidden from you, like behind the scenes. I mean, not hidden, it's open source so you can see it, but you don't have to deal with any of the gRPC connections. That's all already handled. So yeah, I will stop talking and let Edgar talk.
Yeah. Thank you, Kyle.
Sorry, wait, 2 questions before we go.
Yeah.
One asks, can the microcontroller be used to read the GPIOs and publish them to ROS? Not currently. I guess maybe you can clarify which GPIOs you're talking about. These are those on the brain. Then we could do that on the Feather. I don't know that we're reading any GPIOs directly on the dashboard. So yeah, so you can clarify the use case there. Maybe we can talk about it. The answer will be no, it's not supported yet, but it's something we can do. And then Vilo asked, is there a way to add other ROS nodes on the Amiga to interact with the bridge so the Amiga could run things like a path following all on board rather than from a laptop? Yes. What isn't exposed is the GUI interaction on the brain. So it's the ROS container is headless. So you could put path following ROS nodes on the robot and run those. But if you wanted to see, like if you wanted to open RViz or Gazebo or something like that to see what's happening, that would be through a ROS master connection on your desktop. But the actual running should be totally fine on the robot. Okay, all you, Edgar.
Okay, cool. I think I'm sharing screen. I don't know if you can see it. Maybe Ryan, you have to change something.
Oh.
Okay. Someone can confirm that. Yeah. Yeah. Okay. Can we include also the part I'm sharing with the browser too? So basically, I'm gonna go through, as Kyle said, we have these two methods. The one is running the bridge directly in the robot and republish things there. And the second one, which I'm going to walk through now, it's running the bridge on your computer. In my case, the cool thing is that, as Kyle said, I'm based in Barcelona, so what we're going to do now is to run the ros-bridge in my computer here in Barcelona and try to kind of do the same process using this tool to drive the Amiga from Barcelona to in California, where Gran is now. So yeah, let's go for it. So let me go to here to the documentation just to show how I'm gonna do that. So the process is pretty much the same.
Can you
There's,
pause
no
him and just
difference.
ask him to just take a breath
If
while you
you
guys
see
get it
here,
ready so that he's
in
not
the
wasting his time.
method 2 ros-bridge on your PC. So we have actually I think that you kind of skipped that, Kyle. First is that in the repository we also provide, yeah. Yeah, definitely. Yeah. 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 Is it fine now? Yeah. Okay. Yeah. So sorry. Yeah, we're receiving that we have some technical issues with our connection. So yeah, let's keep it for a second like that. Okay. Yeah. Yeah. Okay. Yeah. I think that it's now fine what I'm hearing. So I think I can proceed. Okay, cool. So yeah, I was saying that something I think that we skip at the very beginning is that in the repository, apart from examples, we also provide a couple of ros-launch files. That's the one we have been using here. So the cool thing is that in these ros-launch files, we expose the host and port. So this will allow us to specify specific host. In that case, what I'm going to do is to expose the IP address of the robot over Telescale, meaning that from my computer here in Barcelona, I can just stream and send commands to the robot based in California. So let me go back again to the instructions. So instructions are very simple. I'm gonna just launch this command here in this search terminal. In my case, I went through the process. I'm running this in my local machine. I had to go through the process of compiling. Probably you'll have to do the same and until we release this container containing the binaries. So very simple. It's the same command that Gran and Kyle were showing. It's ros-launch, amiga-ros-bridge. But in that case, what I'm gonna do is I will pass as a parameter to host the IP address of the robot I want to communicate. So this is the IP address of Telescale. So this is the IP address of the robot that you have to figure out depending on the network you are. And the idea is that I'm running this. So in principle, I'm connected. Usually the message you will receive here, it's connecting to gRPC server, and you will see the full address here, which includes the IP address that you specified. By default is localhost. Now I specified this one, and this will be the port of, since we're running the ros-bridge in gRPC mode, this is the port that we use in the robot to expose the canvas, which is the main communication protocol that we are connecting now. And if everything went okay, you will have this message here connected to our PC service. So in theory, now I'm okay. I'm gonna use this second terminal here below just to verify that I can see the topics. Okay, if I do a ROS topic, I see the Amiga command bell and Amiga bell. Next thing I'm gonna try is echo the velocity. So now I'm streaming the velocity from the robot. And again, how it works. So the amiga-ros-bridge is running in my computer. The amiga-ros-bridge has a gRPC client that is connected over the internet to the robot in California, is streaming to my computer here gRPC messages. And since I'm running the bridge in my local computer, the bridge is just taking these gRPC messages and republishing in the ROS as ROS messages locally in my computer. And that's why I can stream using the ROS interface, which is super cool. I'm seeing the velocities from this robot. Actually, we could do the same test that we did before. I'm not sure about the delay. Seems kind of all right, but it would be interesting to see maybe Hector or Gren, if you can drive manually the Amiga, just to verify that I can see the velocities here. Yeah, cool. Yeah, I can see. Very responsive. Yeah, cool. That's very nice.
All right, you have control.
Good. Yeah. Okay. So the second process is again. So probably you notice that the only difference is where you start the ros-bridge, how you specify, well, how you do the configuration of IPs and the communication. The rest is pretty much the same. So I'm gonna try to run also this RQT robot steering interface. From here, I'm gonna drive the Amiga. I'm gonna send some commands just to verify, Gren, Hector, that the Amiga it's good to go. We is it in auto mode?
Yes, it's in auto mode.
Okay. Is it safe to move forward?
Yep, it is.
Cool. I'm gonna start increasing slowly.
Nice.
I see that it's running. I see in my other terminal some velocities. This is very cool. Gonna reduce. Nice.
It's so cool.
Yeah. I'm gonna stop. Man, I mean, it's almost real time. gonna go back. Something's wrong. Not sure. I don't see. Not here. Nice. Whoa, it's amazing. Cool. Okay, I'm gonna stop. So yeah, I mean, that was the last part of the demo. So this morning, so actually that was not planned. This morning with Kyle, we said, hey, can we drive the Amiga from Barcelona or New York using Timescale? And yeah, I mean, the good thing about this infrastructure using ROS and gRPC is that we can stream from anywhere as soon as you have access to the same network. That's the kind of cool feature of our infrastructure for the Amiga. And yeah, and here we are just, it's just a demonstration that we cannot, it's also kind of easy to integrate with known open source packages like ROS, which I guess will be very useful for the community and the Amiga users. So yeah, super cool. Congrats everyone, Kyle, Ren, Hector, all the team. Special thanks also to Hauka. Hauka is also the FarmNG CTO that helped a lot with the implementation of the ros-bridge in Rust, which has been a nice exercise, to learn more about Rust and new technologies.
Yeah,
Cool.
and Chris, of course.
Yeah, of course.
Doing all the infrastructure. Related to that. So Chris has posted a command for you'll SSH into your robot, and then it's a curl command. This is on the discourse to pull the ros-bridge container, and that'll install. And then he's gonna follow up in a couple minutes with a command for doing the same thing to upgrade to version 1.2 on the brain. So that is a requirement because we've added this twist states API. We've added to the CAN bus service in order to use the ros-bridge and communicate using these ROS twist messages. And so you'll need that latest version of the Amiga container, and you'll need to pull the ros-bridge container. So you'll be able to do that in 10 or 15 minutes, I think. So yeah, and then please follow up with questions and anything you run into, so we can help you out with that. Yeah.
Nice. And Gran or Hector, do you have any feedback? User feedback. You are the first ones that you use the ros-bridge. What is your impression here?
It was relatively seamless, and it works well for where we're at. I'm only about an hour and a half in, so I'll get feedback at the end of the day.
Cool.
Sounds good. Well, thank you everybody for listening. Thank you everyone who's here, everyone who asked questions. Thank you, Ryan, for setting this up. Always appreciate it.
Thank you.
And managing the screens and all that. Cool. Like and subscribe. And there's one more, right? Like, comment, and subscribe. So I think we'll start doing more of these technical sessions. I think every week is going to be our goal, and then we also have the more experimental, trying to get the continuous operations on the farm live streams going once or twice a week. Usually those are Tuesday, Thursday in the afternoon, and then these will be Wednesday morning. So would be nice also if you can send to us what would you like to see here. Maybe that's also, I think, a valuable feedback. Because definitely we can make it happen. Awesome.